Right, let's have a look at distance time graphs. There's actually two different types of these graphs that will come up. There's something called velocity time graphs, but that's going to be next lesson. They're a little bit more complicated, a little bit more to it. But let's have a look at some distance time graphs and look to what to look out for. Okay, so this first one, reasonably straightforward. It says how far had the bus travelled before it stopped. So we've got the distance here from the bus station. It's in miles. Just be careful about the scales here. Sometimes you get odd little things here. This is like it's 2 squares for each mile, so you don't want to make a mistake like that. In terms of just miscounting. Coming across, look, that's constant scale again. Each one of these squares would be 5 minutes. So it'd be like half a mile going up, and then 5 minutes, 5 minutes, 5 minutes. Okay, coming across. So how far did the bus travel before it stopped? Well, this is where it stopped, just at this point, just here. And so that's 4.5 miles. Okay, so let's now just I'll make a note of that for you there. Okay, so A was 4.5 miles. And like I said, with all of these, just try and work through them at the same time. Right, now this bit. There's certain sort of terminology that you want to try and use here, and I'm going to go through a few of those things now. It says describe the motion of the bus during the journey. So we basically just want to describe the journey. You don't need to make any stuff up that happened along the way. Anybody you might have chatted to on the bus. But let's have a little look. So in this first 10 minutes, it's a straight line just here. So what that means during that period of time is that it was a constant speed, right? Constant speed through this 10 minutes. All right, so constant speed just here. So the sort of thing that we would want to write down, just write down, so 0 to 10 minutes. The key terminology there is that it's a constant speed. Don't really need a lot of waffle in there, just a constant speed during that point. Okay, now this next 10 minutes. Now you'll notice it's curved. Right, it's curved. It starts to flatten out. So at this point, here, it stops just here. Right, it's stopping. So in this period of the journey, we are decelerating. Right, so we're getting slower. Right, so we're slowing down. So 10 to 20 minutes, we're slowing down. As long as you got that in there, then that's fine. If you can use the word decelerating, then that's even better. Okay, this part of the journey, right? We're not going anywhere. The bus is standing still. It's not moving any further away from our starting point. It's not moving back towards our starting point. So in this period of the journey, from 20 to 35 minutes. Okay, so let's just clarify that. 20 to 35 minutes. Whoops, I'll just move that up a little bit. Okay, we're actually stationary. There we go, stationary. And then the last part of the journey, that goes back from 35 to 60, 35 to 60, and it's a constant speed. Okay, so we just come back. It's just, this is a straight line, so it's just straight back to our starting point. Okay, so it's a constant speed is what we need to know just there. There we go. Right, let's have a look at another example. All right, and let's have a little look at this one. So what have we got just here? So finding speed from a distance time graph. So finding speed, remember to find speed, we need to know the distance and the time. It's distance over time. Alright, so obviously that's what we've been talking about. So we've got kilometers just here. We've got time. So remember, so speed equals distance over time. So speed equals distance over time. Alright, so it's only what we were doing before. So let's have a look. It says find the speed of the train in kilometers per hour at 9:15. So here's 9 o'clock. Here's 9:30. Okay, just here. So 9:15 is obviously slap bang in the middle. 1, 2, 3. 1, 2, 3. Right, but during this period of the journey, it's constant. So it's a little bit difficult to kind of read this off exactly, but I think that point there, I'm going to read this whole section. I'm going to sort of think of this as a nice big triangle here. Whoops, not very good there. I've got 65, I'm going to take that to be. So 65 kilometers just there. And then we've got half an hour. Now remember we said time isn't decimal, so it doesn't actually help if I write 30 minutes. Of course it's 30 minutes. I'll be far better off if I write 0.5 to stand for 0.5 of an hour. So distance over time. So 65 divided by 0.5 equals 130 kilometers per hour. Remember, the other thing that you could have said to yourself is, right, I've gone 65 kilometers in half an hour. How far would you go in 1 hour? Right, find the average speed of the train for this journey. So what we need to know is we need to know the total distance. Okay, so here's the end of the journey, just up here. And our total time. So, yeah, look, there was part A, this is part B. So, remember, speed is equal to distance over time. Okay, so let's have a little look. So it's 150 was the total distance. Okay, I'm looking at the whole thing. Obviously, we've got constant speed here. We stop for a little while. Constant speed here. Stop for a while. Constant speed here. Right, so the average speed of the whole journey, including the stops and the different sections, is going to be total speed divided by the time. Okay, so it's 1 hour, and if I look at this bit, 1, 2, 3, that's 15 minutes just there. So remember, I don't want to write 15 minutes as a quarter of an hour. So I write it like that. So it's 1.25. So if I do 150 divided by 1.25, that will give me 120 kilometers per hour. Alright, there you go. Have a go. See how you get on. And next time we're going to have a look at velocity time graphs. Okay, right, there you go. Well done.